This video is going to be about difference and sum of cubes and the formats for factoring those, but it's good to start with a review of the difference of squares format. It's a good warm-up and kind of the same idea. The difference of squares format says that if we have a binomial, two terms, and there's subtraction between them, we can check to see if the first one's a perfect square and the second one's a perfect square. And if those are both true, then we know exactly how it's going to factor. It's going to be this pattern. So an example of this would be factoring x squared minus 16. We could rewrite this as x squared, which that doesn't really change anything, minus 4 squared. This shows really clearly that this is a difference of squares. It's one thing squared minus another thing squared. And looking at it in this format, we can see that x basically takes the place of what a was here, and 4 pretty much takes the place of what b was here. So we can follow this factoring pattern and get, okay, so x takes the place of a, 4 takes the place of b, x takes the place of a, 4 takes the place of b. So that would be the factored version of x squared minus 16 using that format. We can apply that same format to something that doesn't immediately look like a difference of squares because it doesn't say squared. This says to the 4th power. But what we can see is that 4x to the 4th actually is a perfect square. It's the square of 2x squared. And then, of course, 1 is just 1 squared. So let's look at this part a little bit more. If we multiply 2x squared times 2x squared, so we're multiplying 2x squared times itself. 2 times 2 is 4. X squared times x squared is x to the 4th. We can see that 4x to the 4th really is a perfect square. It's the square of 2x squared. That's why I've written it like this. And so this follows the same pattern that we have here. Something squared minus another thing squared. Something squared minus another thing squared. And so we can follow this factoring pattern. First thing plus second thing. First thing minus second thing. That would be the factored version of 4x to the 4th minus 1. Now let's talk about a sum and difference of cubes. And it's certainly a more complicated factoring pattern, but it's the same general idea that if we can identify something as being a perfect cube minus another perfect cube, starting with the difference of cubes, if we can identify it as being that pattern, then we know exactly how it's going to factor, and we just have to follow that pattern. So this first example, I could write as x cubed, again, that's exactly the same, minus, this is 2 cubed. It fits this format. One thing cubed minus another thing cubed. One thing cubed minus another thing cubed. And we can follow, again, this slightly more complicated pattern. So it's first thing minus second thing, first thing squared, the two things multiplied, and then second thing squared. And that would be the factored version of x cubed minus 8. On the last page, we showed an example of something that didn't look like a square, but it was in fact a perfect square. That's what we did down here. We have a similar example now. This doesn't immediately look like a cube, but it actually is. Here's how we would approach this question if we just got it from scratch and we didn't know that we were specifically doing difference of cubes questions. We would see that this is a binomial, 2 terms, and we'd see subtraction in the middle. So we'd say, well, there's a pretty good chance that it's either going to be a difference of squares or a difference of cubes. They both follow that format. Well, 1 is both a perfect square and a perfect cube, so that doesn't really narrow it down. X to the 6th is also a perfect square and a perfect cube, so that also doesn't narrow down which format we're going to use. But 27 It's not a perfect square, but it is a perfect cube. That means this term's a perfect cube, this term's a perfect cube, and so we can use this difference of cubes pattern. I'll write it as we've been doing with these other ones. 27 is 3 cubed, x to the 6th is x squared cubed. So in total, this term is 3x squared cubed, and then minus 1 cubed. If we're following along with this pattern, that means every place we see a, we replace it with 3x squared. And every place we see b, we replace it with 1. So we've got a minus b, so 3x squared minus 1 times a squared, this squared would be 9x to the 4th, plus a times b, plus 3x squared, plus b squared, or plus 1 squared, which is just 1. And that would be the factored version of this. The sum of cubes pattern is really similar, in fact, extremely similar. So I'll give you a little trick that kind of helps to memorize them, or at least it shows you what the differences are. This formula for difference of cubes, it's for subtraction, and the first term contains subtraction. The sum of cubes formula, it's for addition, and the first term contains addition. In both cases, the second operator is the opposite of the first one. So here, the first term contains subtraction, the second one contains addition. Here, the first one contains addition, and the second one contains subtraction. So there is a pattern to them. Otherwise, the letters or the pattern, everything's in the same place. It's just these two signs are different. So let's do a couple of questions involving a sum of cubes. If we saw this, we would notice there's two terms. It's a binomial. It's two things added. Remember, there's no sum of squares formula, only difference of squares. There is both a difference and sum of cubes formula. So if we saw a binomial with addition, we kind of hope it's sum of cubes because that's the only one we can factor. And we'd say, well, this is a perfect cube, that's x cubed. This is a perfect cube, that's 4 cubed. So yes, it is a sum of cubes. And we can follow the pattern the same way we did on the last couple of questions. So first thing plus the second thing, first thing squared, minus first times the second, plus second thing squared. That would be that one. And we'll do one more with, again, like this question and the one on the previous page. This doesn't say cubed, but we would look at this and say, it's a binomial, it's a sum, so the only possibility is sum of cubes. 125 is definitely a cube, that's 5 cubed. 8's a perfect cube. X to the 9th is a perfect cube, that's x cubed, cubed. And so that's a perfect cube, that's a perfect cube. It is indeed a sum of cubes. So I'll write it in this way that we've been doing these. You don't have to do this, but it can certainly help to visualize it. That's 2x cubed, cubed, plus 5 cubed. If we're following this pattern, A is 2x cubed, B is 5. So we'll just follow the pattern and see how it goes. First thing plus the second thing, first thing squared, minus first times the second, so 5 times 2 is 10, and we're subtracting, so minus 10x cubed, and then plus second thing squared plus 25. And that would be a fully factored version of 8x to the 9th plus 125.